All right, welcome back. We are on lesson 1-2, which is in your book, and it starts on page 29. Here, just a reminder that you can rewatch the video when you're done. You can follow along in the book. This time you should have your book open and be following along as I'm going through the examples in the chapter. And you can also watch personal tutor videos and the resources of the online textbook, which I know we still haven't gone over in class. So we will, but there are directions on Moodle. So the learning target for lesson 1-2, I can evaluate algebraic expressions using order of operations. I mentioned in class that I think it's important to label your notes. So on the top of your notes, you should write 9, 4, 14 and label it 1-2. You can even write video or notes next to it. So we hear the word algebra all the time, and there's a few different things that go along with the word algebra. Algebra can be broken up into numeric expressions and algebraic expressions. So numerical expression examples, what we're used to working with, 3 plus 2, 4 times 9, 6 times 5 squared. They have numbers in there, and we can evaluate our numerical expressions. We know that, I'm dropping my marker here. We know that 3 plus 2 equals 5, 4 times 9 equals 36, and 6 times 5 squared equals 105. Okay? We also have a algebraic expression. Okay, so we have numerical expressions include just numbers. Algebraic expressions have numbers and a letter or letters. Okay, for example, a plus 2, 4n, 6x squared. The letters a, n, and x are called variables, which I know that you've heard before. So our variables represent a number that we do not know and we usually are trying to figure out. So we have numerical expressions and algebraic expressions. So talking about multiplication, we are a lot of times used to using an x for multiplication. So 2xn would be the same as 2 times n. Now that we're in algebra and we're going to be using variables a lot, and remember a variable is a letter, a lot of times we use x for a variable. So 2xn can be kind of confusing. Once we're used to working with variables, we aren't sure if it's a multiplication or if it's a variable. So we can also write it as 2n, 2 and then parentheses, n in parentheses, so 2 parentheses n, or 2 with a little dot n. So all of these mean the same 2 times n. Okay? If we are talking about exponents, which we talked about in class today, 7, if we have 7 squared is the same as 7 times 7, which equals 49. Okay? This does not mean 7 times 2, it means 7 times 7, and then our answer is 49. Okay? X cubed just means x times x times x. So if we have 2 cubed, it would be 2 times 2 times 2, which is 8. Okay? Exponents are also called powers. So it's 7 to the power of 2, x to the power of 3. So if we are given algebraic expressions and then we're given what our variables equal, we are able to evaluate our algebraic expressions. So this is coming right out of your book on the example page. On page 30. Okay, so if you just read along and look at the example, I'm not going to go over all these, but if we look at number 1, it says evaluate 6 times x minus y squared if x equals 7 and y equals 4. Well, notice that x equals 7, y equals 4. Oops, I accidentally covered up the 7. We put our 7 in place of our x, and we put our 4 in place of our y. And then we have to think back to our order of operations, the PEMDAS, and go in order to solve, and then we get 54. Okay, so let's do this one right here. So if we have 6c plus 4 minus 3d, and we're told that c equals 3 and d equals 7. So we have 6, and I'm going to plug in my numbers for my variables, and I'm just going to write it in parentheses so that I know, because 6c is the same as 6 times c, 6 times 3. So 6 times 3 plus 4 minus 3 times 7, because c equals 3, d equals 7. And we just substitute it in. Now I'm going to solve my equation. So I know that I do multiplication first. So this is where it's a little confusing, because even though it's parentheses, this is still multiplication. This is multiplication. So I have 18 plus 4, bring down my subtraction, and then I'm going to do 3 times 7, which is 21. Okay? And then I have 18 plus 4 is 22 minus 21 equals 1. And I do my addition and subtraction from left to right. Okay? So I want you to, we're going to actually go on because I have more problems on the next page that we're going to do. Okay, so let's look at this. So we have another way to write division. So we can write division like that. We can also write it as a diagonal line, like 4 divided by 2. We can also write it with a bar, 4 divided by 2. So all of these have a bar in them, which means division. So we're going to do the same exact thing. This time P equals 5 and Q equals 12. So I'm going to rewrite D, putting in my P and my Q. So we have 3 times 5 minus 6 over 8 minus 5. And then I'm going to solve it. And I do everything on the top and everything on the bottom. So I'm going to do 3 times 5 is 15 minus 6 equals 9. And then 8 minus 5 equals 3. This means division, remember. So 9 divided by 3 equals 3. Okay, let's do this one. 4 times 12, I'm putting my 12 in for my Q, over 12 plus 2 times 5 plus 1. Okay, and now we're going to solve our top separate and our bottom separate. Okay, so we have 4 times 12 is not 42. See, I make mistakes too. 48. And then I have, so I'm going to do my parentheses first. So 5 plus 1 is 6, times 2 is 12, plus 12 is 24. 48 divided by 24 equals 2. Okay? Pause me really quick and do F, and then come back and check your answers. So we have 12 squared, 4 times 12 minus 2. 144 over 4 times 12 is 48 minus 2 is 46. 144 divided by 46 should be 8. And I'm just noticing that it's in your book on the bottom of the page, so hopefully you did it without your notes or without looking in the book. Okay, moving on, talking about properties really quick. I know that you've talked about these before, probably in 6th grade. This could be a review. But if you read right up on the top here, a property is a feature of an object or a rule that is always true. Following properties are true for all numbers. Okay, so if we look at commutative, commutative is the one that you can just flip around. So a plus b equals b times a times b equals b times a. It works for addition and multiplication. Okay? Okay, and then associative, we have our parentheses just change, but everything stays in the same order. So we have a plus and then parenthesis b plus c equals parenthesis a plus b plus c. So we just change our parentheses around. This works for addition and multiplication. Distributive, which we will talk more about later on. I'm actually going to skip distributive right now. Identity property is if whatever you're, so for addition, if we're adding, I feel like this is kind of hard to see. Anything plus 0 is just going to be that number. So 9 plus 0 equals 9. Negative 2 plus 0 equals negative 2. 1 plus 0 equals 1. And then for, so this is for addition, and then for multiplication, anything times 1 is itself. So we have a times 1 equals a. 4 times 1 equals 4, and so on. So I want you to, without looking in your book, look at example number 4 and name the property shown. So we can see here 2 times and then parenthesis 5 times n equals parenthesis 2 times 5 times n. So see how our parentheses change from here to here. So we know it's the associative property of multiplication, and we say multiplication because we're working with multiplication. So look at G and H and see if you can figure out what the property is for G and H. So take a second. And we have 42, and you can see plus x plus y, and then we keep it 42, but we're changing the order of the y plus x. So even though 42 isn't the same, we're still going to call it commutative, and we would say commutative property of addition, because we're using addition. And 3x plus 0, for adding 0 here, this would be called, we would call it the identity property of addition, or you can just say the identity property. Okay, we are going to skip this page for now, and I believe then that is it. So you can go back and rewatch the video if you're still feeling a little unsure about the order of operations or the PEMDAS. You can go back and do a couple more problems, or you can do a couple more problems on the back of the worksheet that we did in class today. Remember that now that you're done watching the notes, or watching the video, you should have a sheet full of notes and that you need to go on to NICU and watch the quiz. Have a nice evening, and I'll see you tomorrow.